miles an hour.
I think the plush.
It has a lot of surface area about his arms.
We're at 18,
Yeah, it's gonna be the slide. Yeah,
20. It is gonna be Mr. Sloth.
Whoa.
Where he's flying at about 23 miles an hour. He is a stable flyer like you. He generally flies belly down with his arms and legs out. Right now, your flight instructor's doing a burble. He's creating a burble, which means he's blocking the air, causing Mr. Sloth to come down into his arms. Maybe he'll do that again. There he goes. That's called creating a burble. Lovely. Okay. Now, somebody guess who, wiffle ball or yoga ball, right?
That one's like stuck in there.
It's not stuck, it's just very aerodynamic. I know it looks like it's stuck. Alright, we're at 30 miles an hour. It's
Whoa.
too much. Alright, wiffle ball. The holes in the ball actually help it to be a stable flyer because the air goes in the bottom and then spins and goes out the top. So you can see that one on the far side is just spinning in midair. These are also stable flyers, meaning they're not going to like be bouncing all over the place. Look at the yoga ball. He is not a stable flyer. In a moment, he's going to be bouncing everywhere, and that's because of the surface of the ball.
Whoa. Whoa.
The surface of the ball has those ridges on it. The air catches the ridges, causes it to go everywhere. That's why we don't make round airplanes. That one, yep. All right, let's talk about that green one. We call this the googly ball. It's a rubber ball. It's got little rubber fingers on it. The rubber fingers actually help it to be a stable flyer. But he's going to give it a spin. It's going to change the frontal area, and then what happens? You need to do that again. There we go. When it gets more frontal area, it will fly higher. We're good. All right, so now we have two basketballs, same weight, different frontal area, and that football. We are at 37 miles an hour, 38, 39, 40. Which basketball do you think will go first?
The colorful one.
The purple one? They're the same weight, but different frontal areas. You know what, they might kind of go at the same time, because they're so close. Generally, the bigger one goes first because it's got more frontal area. All right, he's going to show us a scientific, I don't know what to call it. The effect. He's going to show us the Magnus effect. That was not it. All right, here we go. When he spins the ball into the wind, it kind of ricochets or boomerangs back to him. That's called the Magnus effect. This is how a pitcher learns to throw a curveball, learns to control his curveball. Yeah. All right, so we have that one basketball, the small one, and the football. We're at 56 miles an hour. It's going to take a lot of wind to get that football off the net because it's so aerodynamic. All right, this one's flying at 61. There's the Magnus effect. Beautiful. Yeah. All right. How much wind do you think it's going to take to get that football off the ground? 100? When he changes the frontal area, it'll fly right up. But as it is right now, it's too aerodynamic. Can you hear it whistling? Yeah. That's little whistles on the side of the ball. We're currently at 77 miles per hour. It's kind of flying, but it still wants to. Oh, there he goes. the sand. So its flight pattern is going to be very wiggly and odd. So if they're both on the net, who do you think will fly first? The ball or the flight instructor?
The flight instructor.
Oh, you're so smart. We'll see where he flies at. About
He has more
80,
surface area.
90, about 95 is when he takes off. 116, the ball is gonna fly. The shifting of the sand is what makes it very, very, very wiggly. We're at 124 right now. It's really hard to catch that ball. The next thing, we're going to pour some water into the wind. What do you think will happen when we pour a liquid? It'll go up. How will it go up?
By molecules?
By molecules, she said.
Not molecules. Like bubbles.
Bubbles? Alright, we have to get the wind speed down because the terminal velocity of water is about 22 miles an hour. So in order for you to see it, we need to get the wind speed down a little bit. Yeah. Let's look and see what happens. It is going to be bubbles. If you're close enough to see, these bubbles will be the same diameter. They're going to be flat on the bottom, but curved on the top like a hamburger bun. They're going to be the same size, and he can control whether they're moving up or down based on the wind speed. So the air has enough power to break the surface tension of the water. They will also bounce off the net every once in a while, you know? Yeah. We're good. So now we just have a big mess inside the tunnel. How can we clean that off? A bunch of wind, that's right.
That too.
He's going to show you some, I don't know if he's going to show us some technique or if he's just going to do some tricks. We'll see.